Find the magnitude and direction angle of the resultant vector. Resultant vector means you're going to take, I don't know, a vector or two or more and like add, subtract, multiply, do stuff to it to get an answer. Resultant vector. In this case, we're taking a and b, and we're multiplying -3 to a, and we're subtracting 7 times b. Let's find out what that is first. So -3a is going to look like this, and then we're going to do -7 times b, which is going to look like this. Okay, multiply. Whenever you have component form, just multiply. That becomes 9. That becomes 36. Same thing again, multiply positive. That becomes, I'll throw negatives in there, -28, -63. And then when you add these guys up together, you get -19, I think, and -27. All right. Let's get a nice little visual going. Okay, -19, -27 means in order to draw this picture out, you go left 19, you go down 27, and then you have something that looks like this. Now, fig number 1 is you went left 19, you went down 27, so I have myself a Pythagorean theorem-ish type problem, which that's how I'm going to do this first part. But I'm going to use more of this formula now. I'm going to move away from a squared plus b squared equals c squared and move more towards the radius version of it, which it's the same thing. In fact, it's not going to be by saying it's the same thing, I actually started writing out the same thing, which is the opposite of what I wanted to do. R equals the square root of x squared plus y squared. You've seen that. So in order to find the magnitude r is going to equal the square root of 19. Actually, we'll put -19 just to prove the point that this becomes positive. We're going to be consistent. And -27 squared. I'm going to do this mentally and not use a calculator and find out that this becomes 33.015. Big brain. Now, what I have to do is I have to find also the direction angle. Now, if this is a coordinate plane, I've got 90 up here, I've got another 90 here, and I care about that theta. I need to find theta and then add 180 degrees to it. So I do know that tangent theta equals the opposite over the adjacent. So 27 over 19. In order to get theta all by itself, we're going to inverse tan, which means you stay in the shadows. Get it? And that gives me a theta of 54.865. Did that in my head too. Now that's just this part here. In order to get the direction angle, I have to include the fact that it starts over on the right side of the x-axis and winds its way around counterclockwise. So 180 plus this is going to give me 234.865 degrees. So that's my direction angle. This is my magnitude. And that's the problem. Dunzo.